Okay, so this is how we'd represent a covalent bond using our electron dot structures. You can see that there are three rules here on the right. They're very simple, but it really becomes kind of a trial and error, and that's why this problem may take you a little bit. So the first thing we're going to do is draw the dot structure from each atom that we see in the molecular formula. And up at the top we have H2O2. So I'm going to draw two H's and two O's, which you see here on the page. And now I'm going to look to pair electrons. Hydrogen is an exception. It only needs two electrons to be satisfied, to be happy. And so with that in mind, I'm going to try to pair these together. So I'm going to start out and say, okay, well, this oxygen needs two electrons. And so I'm going to bring in those two H's. The problem is that if I do that, then this guy, oxygen, is left out in the cold, and he has to be a part of what is going on. So this is not going to work. That is incorrect. So I got to start over. So let me try again. Let me put my oxygen in here, and instead of bringing the H's in first, let me bring in the other oxygen first. And you notice that I can move or reorient the electrons as long as the pairs stay the same. So here's a pair on top, here's a pair now just on the other side, and then one electron on the bottom, and now I'm sharing that electron in the middle with the other oxygen. But if we count them up, these electrons only make 7. If I look at the yellow X's with the red dot, 1, 2, 3, 4, 5, 6, 7. And same thing with the other oxygen. So I'm in luck. These are gone, but I need, or can use, the other two H's. So I'm going to bring in them and have one share here, and it's happy because now it has two. Remember, it's the exception. And the other one here. And now, if I count, oxygen has, and I'll use a marker here, 1, 2, 3, 4, oops, that's not what I wanted to do. 1, 2, 3, 4, 5, 6, 7, 8. It's happy. The other oxygen is happy. It has 1, 2, 3, 4, 5, 6, 7, 8. And then the two hydrogens are happy because they have 2.